So now that we have the key terms out of the way, let's talk about probability. So what is probability? So our intuitive idea of probability is a measure of how likely an event is to occur. When an experiment is performed. Okay? So for example, if we're tossing a coin, the probability that we toss a coin and it lands on heads is 50%, right? This is a probability that we have an intuitive idea of, right? You could either land on heads, you could land on tails. There's a 50% chance that you'll land on either one of them, right? So the probability that we toss a coin and it lands on heads, that event happens, is 50%, okay? Probabilities are always between 0% and 1%. Probability is always between 0% and 100%, because we cannot have the chance that something happens cannot be less than 0%, right? You cannot have less than a 0% chance that some outcome occurs, right? 0% chance means there's no chance. You cannot have less than a no chance, right? And similarly, 100% chance means it's guaranteed to happen if we perform this experiment. And you cannot have a probability higher than that. You cannot have a likelihood greater than guaranteed to happen, right? So probability is always between 0% and 100%. Now, we often talk about probability in real life in terms of percentages. But in math, it's actually much more useful to talk about probability in terms of decimals, okay? So instead of 50%, we would say 0.5. So in math, it is more useful to use decimal values when speaking of probability. So for example, instead of 50%, we would say 0.5. And so with this in mind, this rule here, the probability is always between 0% and 1%. If we think about it in the decimal form, probability is always between 0 and 1. Probability is always between 0 and 1. So that's if we're in decimal form. We're not dealing with percents. Okay? So how do we represent probability? We denote the probability of some event E as P of E. So here P is capital and E is the event we're getting the probability of. Okay? So for example, if H is the event where a coin is tossed and it lands on heads, then the probability that H happens is 0.5. Okay, because it's a 50% chance if you toss a coin that lands on heads, right? This is the probability that heads happens, and we're using the decimal form instead of the percentage. Okay? So the idea with probability is that it is the long-term proportion of what happens if we repeat the experiment many times. Okay? This is called the law of large numbers. Okay? If we repeat an experiment many times, the proportion of outcomes that result in an event. Okay, so the proportion of times an event happens. Okay, the proportion of outcomes that result in an event is, let's say, gets close to the theoretical probability of the event. Okay, and this is really the key of why we care about probability. So let's think about this for a moment. Let's go back to our coin tossing example because it's a simple example. So say you toss a coin twice. Okay, what would you expect to happen? Well, you know, maybe one of the time it comes up heads and another time it comes up tails. That would be, you know, half the time it comes up heads. That would agree with our probability. But we wouldn't be shocked if that doesn't happen, right? Maybe we toss the coin 2 times and both times it comes up tails, right? We're not going to go, oh, probability has failed us, right? It happens, right? Each time we toss the coin, it's random. And so it's possible that both times it comes up tails. It's not that unusual, okay? Now, what if we do it 10 times? What if we toss the coin 10 times? Well, then that would be a little unusual if we didn't get any heads, right? If we tossed that coin 10 times and it came up tails every single time, that would be a little bit odd. Not just a little bit odd, that'd be very odd. That doesn't happen very often, okay? But also, we wouldn't be like completely shocked. Our faith in the universe wouldn't be shattered, right? It'd just be like, oh, that's weird. Now, what if we took that coin and we tossed it 1,000 times? Now, the chance that it comes up tails all 1,000 times is so remotely small as to be practically zero. It is almost impossible for that coin to come up tails 1,000 times. Okay? Technically, it's possible, but it's so rare that's unlikely to happen. What is likely to happen? Well, if we toss the coin 1,000 times, some of the times it's going to come up heads, some of the times it comes up tails. And we're doing it so many times, we expect the number of times it comes up head to be about half. We expect very close to half the times we flip this coin for it to come up heads, and close to half the time we flip this coin for it to come up tails. Okay? So I actually used a computer and simulated this experiment. So let's see a graph of what I got here. So I used a computer to simulate 1,000 coin tosses. Okay? So the vertical axis here tells me the proportion of heads. This is the actual observed proportion. Remember, the probability, which is 0.5, that's what we would expect to happen. Okay? The blue line here tells us what's actually happening. And then on the horizontal axis, it's the number of coin tosses. So what's the proportion after just one coin toss? After 100 coin tosses, 200, 300, all the way to 1,000. Okay, so let's see what happened. So right off the bat, we tossed the coin 1 time, and what did we get? We got tails. I know because it's not up here, it's down here, right? So we had tossed the coin one time and we didn't have any heads, so the proportion of heads is 0. We didn't have any heads. But pretty quickly, we kept on tossing that coin, or had the computer simulate tossing the coin, and it went up, right? We could see over here, though, that when we had only a few coin tosses, the proportion, it swung around quite a bit, right? It went up and then down and then up again, okay? But as we toss the coin more and more times, this blue line gets more and more predictable, doesn't it? Okay, so while if we only toss the coin a few times, it's not uncommon to have a lot of tails, okay, or maybe an unusual number of heads. But the more we toss the coin, the closer we are getting to the theoretical probability. By the time we get to 1,000, it is practically on the line. Okay, the number of heads just about equals the number of tails when we've tossed that coin 1,000 times. Okay, that's the law of large numbers. Now, this is a really interesting law because the experiment itself is totally random as far as we're concerned, right? We toss a coin, we have no idea if it's going to come up heads or tails at one time. But if we do it lots of times, we can predict the proportion of heads we are going to get. And that's what's really cool about probability. We could take something completely random, and if we repeat it, we can get some predictive power from that. Okay?